Synthesis and biological evaluation of anti-cancer agents that selectively inhibit HER2 overexpressed breast cancer cell growth via downregulation of HER2 protein. Compound JCC76 selectively inhibited the proliferation of human epidermal growth factor 2, HER2, overexpressed breast cancer cells. In the current study, a ligand-based structural optimization was performed to generate new analogs, and we identified derivatives 16 and 17 that showed improved activity and selectivity against HER2-positive breast cancer cells. A structure-activity relationship, SAR, was summarized. Compounds 16 and 17 were also examined by Western blot assay to check their effect on HER2 protein. The results reveal that the compounds could decrease the HER2 protein, which explains their selectivity to HER2 overexpressed breast cancer cells. Furthermore, the compounds inhibited the chaperone activity of small chaperone protein that could stabilize HER2 protein. Cyclooxygenase 2, COX-2, inhibitor nimesulide inhibits the proliferation of various types of cancer cells mainly via COX-2 independent mechanisms, which makes it a good lead compound for anti-cancer drug development. In the presented study, a series of new nimesulide analogues were synthesized based on the structure-function analysis generated previously. Some of them displayed very potent anti-cancer activity with IC50s around 100 nm to 200 nm to inhibit SKBR3 breast cancer cell growth. Gzua 0901, INS C751382, from the compound library also inhibits the growth of the 60 cancer cell lines used at National Cancer Institute Developmental Therapeutics Program, NCIDP, with IC50s around 100 nm to 500 nm. Intraperitoneal injection with a dosage of 5 mg/kg/df. Gzoa 0901 to nude mice suppresses HT29 colorectal xenograft growth. Pharmacokinetic studies demonstrate the good bioavailability of the compound. Third-generation aromatase inhibitors, A.I.'S, are more effective than tamoxifen in the treatment of estrogen receptor, positive breast cancer. However, long-term use of A.I.'S commonly results in resistance. We examined whether compound JCC76 cyclohexancarboxylic acid, 3,2,5-dimethylbenzylic-4-methanesulfonylmethylaminophenylamide, an analog of cyclooxygenase 2, COX-2, inhibitor nimesulide, can inhibit the growth of AI-insensitive breast cancer cells and the mechanisms by which the compound affects cell proliferation. Lett, long-term estrogen-deprived MCF7 cells, which are a model for AI resistance, were used in this study. JCC76 effectively inhibited Lett cell proliferation with an IC50 of 2.75 ± 0.31 μm. Further investigations reveal that the compound significantly induced apoptosis in Lett cells by decreasing PACT, BCL2 and PBAD protein levels, which were all upregulated in the cells after long-term estrogen deprivation. Lett tumor size and weight were decreased in ovariectomized nude mice treated with the compound, and cell apoptosis in the tumor tissue was increased compared to the control. The animal weight remained almost unchanged, which indicated the low toxicity of the compound. These results suggest that JCC76 overcame AI resistance by inducing cell apoptosis as illustrated in the in vitro and in vivo models. Collectively, results from this study provide data to support that nimesulide analog JCC76 may be a new drug candidate to treat AI-resistant breast cancers. It could be also used as a lead to design and synthesize more potent derivatives.